Hello friends, welcome to my channel in Chemistry. Please subscribe and hit the bell icon. So let's start. So today we will do some formula based question which is very simple formula. You can see one by one. The questions are what frequency in megahertz is required to cause a proton flip its spin flip when it is exposed to a magnetic field of 1 Tesla. So the frequency is asked. So the formula is very simple. You can see this is nu, that is the NMR spectrometer frequency, that is in megahertz. So equal to gamma by 2 pi B0. Gamma by 2 pi B0. This gamma is nothing but gyromagnetic ratio for proton, that is 26.75 into 10 to the power 7 rad Tesla inverse and second inverse. And we can put the 2 and the pi and then B0, that is the magnetic field strength, that is given 1.0 Tesla. And if you calculate this, you will get 43 megahertz. So 43 megahertz is required to cause a proton flip its spin when it is exposed to a magnetic field of 1 Tesla. Now come to the next question. Calculate the magnetic field in Tesla required to flip a 1H nucleus in an NMR spectrometer that operates in 360 megahertz. So this is also very simple. So what we have to calculate, that is B0. Calculate the magnetic field here is given. In the previous question, frequency we have to calculate, and in this question we have to calculate the magnetic field strength. So B0 equal to, just you have to multiply with this and divide with gamma and nu into 2 pi by gamma. So putting all the values, that is nu, that is 360 megahertz, mega means 10 to the power 6, 360 into 10 to the power 6 into 2 into pi by gamma is nothing but 26.75 into 10 to the power 7. This is for proton H1 nucleus only. For carbon 13, that will be a different value. So if you calculate, you will get 8.46 Tesla. Now come to the next question, that is what strength magnetic field is required when a 500 megahertz instrument is used for 1H NMR. So this is also very simple. You have to calculate B0. So put the formula and get the answer. Nu upon, that is nu upon gamma into 2 pi. So 500 into 10 to the power 6, this is instrument NMR, that is 500 megahertz, 500 megahertz into 2 into pi, and that is gamma is the gyromagnetic ratio 26.75 into 10 to the power 7 for 1H NMR. So if you calculate this, you will get 11.75 Tesla. Now come to the next question. How many hertz from the TMS signal is the signal occurring at 2.0 ppm? So if you see the NMR spectrum, there will be a TMS that is around 0.0 ppm, and corresponding to that TMS we are getting 1 ppm, 2 ppm, like that. So if you record how many hertz from TMS signal, the signal occur with 2.0 ppm. So if you are using a 300 megahertz spectrometer, that 2 ppm will be how many hertz? So that we have to calculate. So if you know the formula, that is the chemical shift in ppm, that is downfield form TMS in hertz by operating frequency in megahertz. So if you calculate for both the values, if you see the chemical shift value is given, that is 2 ppm. So we have put that chemical shift value. Now you have to calculate the TMS in hertz, that is how many hertz, that is asked in question. So x hertz, we will take x hertz. Now operating frequency will be 300 megahertz in question number A and 500 megahertz in question number B. So if you calculate, you will get x. So for x we will know that is 600 hertz, and for this 1000 hertz. So this is nothing but in 1 ppm this will be 500 megahertz, 2 ppm twice of that, 3 ppm thrice of that, 4 ppm into 4. So we have to calculate only if you multiply with megahertz, this is 500. So if you multiply with only 2 ppm, you will calculate in hertz. So this is very simple because ppm is in parts per million. You can see ppm in parts per million, and that is 1 by 10 to the power 6. And when megahertz is multiplied, you will get in hertz. So this is very simple question. Now come to the next question. That is, a signal is seen at 600 hertz from the TMS signal in a NMR spectrometer with a 300 megahertz operating frequency. So now the question is, what is the chemical shift of signal? First question is, what is the chemical shift of the signal? Then second question, what is the chemical shift in instrument operating at 500 megahertz? And the third question is, how many hertz from the TMS signal is the signal in a 500 spectrometer? So we will see one by one. A signal is seen at 600. So before we have seen how to calculate from ppm to hertz. So this is signal seen at 600 hertz from the TMS signal in a NMR spectrometer with 300 operating frequency. So 300 megahertz means in 1 ppm that will be 300 hertz, and for 2 ppm that will be 600 hertz. So what is the chemical shift value? Because it is 600 hertz, that will be 2 ppm. So the formula is very simple. 6 hertz by megahertz we will get in ppm. So 600 hertz by 300 megahertz we will get 2.0 ppm. Now come to the next question. What is the chemical shift in an instrument operating 500 megahertz? So if you know the concept that chemical shift value will never change if you change the NMR spectrometer's magnetic field strength. That is, if you go from 300 to 500 to 700 to 900 like that the chemical shift will never change. Okay, you have to remember this. The chemical shift will always remain the same. Whichever NMR spectrometer you taking, the chemical shift value will never change. Now come to the third question. So that will be only 2 ppm. For 500 megahertz also that will be 2 ppm. Now come to the question number C. How many hertz from the TMS signal is the signal in a 500 spectrometer? 500 megahertz spectrometer, how many hertz? So we have to calculate in hertz. So x hertz by 500 megahertz equal to 2 ppm. So x will be 1000 hertz. So 1000 hertz downfield from TMS will be that signal. Now come to the next question. If two signals differ by 1.5 ppm in a 300 megahertz spectrometer, by how much they do differ in a 500 megahertz spectrometer? So there are two signals, and two signals are differ by in hertz. They have given in hertz. Okay, they have given in ppm, 1.5 ppm in 300 megahertz spectrometer. So if you see that is 1.5 ppm, that is the two signal difference, each 1.5 ppm. How much do they differ in 500 megahertz? So we have already known that the ppm value will be never change. So the difference in 300 megahertz is 1.5. So the difference in 500 megahertz also will be 1.5. So that is the difference will be no change, I think. This is the answer. The chemical shift is independent of the operating frequency and of the spectrometer, therefore that will differ by 1.5. So that will be answer will be 1.5, that remains same. Now come to the next question. If two signals differ by 90 hertz in 300 megahertz spectrometer. Now if you see, this is given in hertz. In before question if you see that is given in ppm, but now this question is given in hertz. Now if you calculate like that, you may end up with wrong answer. So we have to do that. How I will do that, you will see in the answer section. So if two signals differ by 90 hertz in 300 megahertz spectrometer, by how much they do differ in a 500 megahertz spectrometer? So in 300 megahertz they are differ by 90 hertz. 500 megahertz how much differ? I have to calculate. So this is the answer. You can see hertz in megahertz is ppm, we know. So 90 hertz by 300 megahertz will be some ppm. We know that in 300 megahertz the ppm will not change. Also we will take, if you 500 also, that will be remain same. So in 500 megahertz we have to calculate the x, that is how many differ by 90 hertz in 300. We have to calculate differ in how much in 500 megahertz. So this x will be calculated very easily. You can say x equal to 150 hertz. So they differ by 150 hertz. So these are typical simple question which are asked in CSR net and GATE examination. So thank you for watching this video.